Welcome to another episode of Terry's Notes, and I'm going to be looking at the January 2016 paper, question 10. I got complaints that the audio stopped close to the end of the video, as well as some students were having trouble viewing the diagrams. They said it was unclear. Okay, so this is just an updated video. And in the first part of the question, we have a circle and we have a sector HOK. We have a chord which is HK, and we want to find the area of the minor sector HOK. Alright, now so the area of a sector is given by theta over 360 multiplied by pi r squared. Right, so the angle given is 40 degrees, so it's 40 degrees divided by 360 multiplied by pi, which they told us to use as 22/7, multiplied by r squared, which is 21 squared. Right, and if we use our calculator, we are going to get hold on one sec, let me just use the calculator here. So we get 154 centimeters squared. Okay, so that is the area of the minor sector HOK, right, which represents this shaded area that I am illustrating here. So the next part of the question asks to find the area of triangle HOK, right, which is this shaded region here. Now, if we have a triangle and we have one angle in the triangle and we know the lengths on either side of the angle, right, so we have angle theta on two sides A and B, the area of the triangle is given by a half AB multiplied by sine theta, right? So if we look at the triangle that we have here, we have a similar situation. So it'll be a half multiplied by 21 multiplied by 21 again. Alright, this side here is 21 as well because it's a radius, multiplied by sine 40 degrees. Okay, and we use the calculator again. And we get 141.7 centimeter squared. Okay, so this is the area of the triangle HOK. The next part, we want to find the area of the shaded segment, right, which is this area here. So the area of the shaded segment will be the area of the sector HOK minus the area of the triangle HOK. So this will be equal to 154 minus 141.7 which will give us 12.3 cm squared. Okay, now in part B we have a circle geometry question. And the first part, we want to find angle ADC. Now AC is the diameter of the circle, because AC passes through the center of the circle, right? So therefore angle CDA is 90 degrees. Right, now we want to get angle ACD. Right, so if we look at, we want to find ACD. Now ACD will simply be half of 72 degrees, right? So half multiplied by 72, which will give me 36 degrees. Right? And the rule for that is the angle subtended by a chord at the center of a circle is twice the angle that the chord subtends at the circumference, standing on the same arc. Right? You need to be able to give the reasons, especially with circle geometry. So those are things that you have to learn off, right? Some students tend to avoid this question, but it's a very easy question once you know the rules. So ACD is 36 degrees, right? Now you want to get angle CAD, right, which is this angle here. So we have a right angle triangle. We know that one angle is 36 and one angle is 90 degrees. So therefore CAD is equal to 180 degrees minus, open brackets, 36 degrees plus 90 degrees. And that gives me and that gives me 54 degrees, right? Now we want to get angle OEA. So we have another triangle here. We also know that TAE is a tangent to the circle. So therefore angle OAE is 90 degrees. Right, so this is 90 degrees here. So we have 90 degrees and 72 degrees, and we want to find OEA. So OEA is equal to 180 minus 72 plus 90, and this will give us this will give us 18 degrees. Okay, so angle OEA is 18 degrees. Right.